Hey everybody, this is Dr. Jacobs, and for this first week, I kind of wanted to ease you into the class. I know a lot of people can be super anxious about taking statistics, especially trying to take it online. And so what I like to do, I started doing like about a year ago, is doing some sort of math review because I don't look at statistics as a math class, which is one of the biggest misconceptions. I see it more as a language class, and I'll keep talking to you all about this as we move through the semester. But really, all the math that we're going to be doing in this class are things that you have probably done before, but it's probably been a really long time. So let's go ahead and get started with our first lecture. All right, so if we're looking at this problem, in the following math problem, what do you solve for first? So let's think back to order of operations and think about, okay, if you're presented with this problem, what are you going to do first? Now, don't answer this in the perusal. Just answer it out loud in your head, and then you can check yourself in a minute. All right, so what is this question? Testing. It's testing if you know the order of operations, which will become important because although we're not going to be doing any new math, we will be doing some complicated formulas at some point where you'll have to apply order of operations. All right, so the answer to this is you're always going to do those parentheses first. We'll read it left or right. So we'll do the 5 times 3 first because that's the first parentheses that we have. All right, so if we look at order of operations, and it might have been a really long time since you've had to do this, we always are going to do in a particular order. Sometimes people like to use the mnemonic called please, excuse my dear Aunt Sally to kind of try to keep the order of operations in their brain. So we're always going to start with parentheses. So we'll do our parentheses first. Then the next thing that we do is any exponents that we have. And then so what's confusing for some people is the next one, multiplication or division, actually is which one comes first. So if you have a division that becomes before a multiplication, but it's to the furthest left, you're going to do that first instead of the other. Okay, so here we have parentheses, then you do your exponents, then you do multiplication or division, depending on what's the furthest left, and you follow it left or right. And then after you've done your multiplication or division, you do something similar and you either do your addition or subtraction and you follow it left or right. So if you have an addition problem furthest to the left, you'll do that first. Or if you have a subtraction, you'll do that one first. All right, so what is the square root of 36? Again, don't answer these in the perusal comments. These are for you to practice. But if you do have some questions about how to do square root or stuff like that, go ahead and put those in the comments as well. Okay, so the symbol like that symbolizes that we're wanting to do the square root. And if we take the square root of 36, we get 6. What's the opposite of square rooting something? So think about that for a minute. Shout it out loud while I'm Dora the Exploring you. What is the opposite of square rooting something? So squaring is the opposite, which is represented or symbolized by a superscript 2. All right. So for example, if you take 6 and you square it, you get 36. And if you take the square root of 36, you get 6. Okay, so we can see how they're inverses of one another. That becomes important later on when we're doing some problem solving about some of the formulas that we're going to see in this class. So when I tell you or direct you to find the sum of 5 and 7, what am I telling you to do? If I say, hey, find the sum of 5 and 7, what do I want you to do? So in order to understand that sentence, you have to know what the word sum means. Okay, so what does the word sum mean? It means to add. So if I'm saying, hey, add 5 and 7, I want you to add 5 and 7 together if I want you to sum them together. And that'll become important. We'll have a symbol that we're going to learn pretty early on called the summation symbol that tells you to add certain things together. And so if you can remember that when we say sum, that means to add, and that'll help us out when we're trying to problem solve some things later on. So then what happens to a negative number if you square it? So we remember if we square something, that means we take a number times itself. So if we multiply a negative number by itself, or we square a negative number, what happens to it? Okay, so when we square a number again, we multiply it by itself. And if we do an example, we can see what happens, right? So if we take -1 and we square it, it's -1 times -1. And we find out that it becomes positive. It becomes +1. So anytime that we square a negative number, it will become positive. What happens if you take the square root of a negative number? This one's going to be reaching back probably to some math that you haven't had for a really, really long time. So what happens if you take the square root of a negative number? It becomes an imaginary number. We won't be dealing a lot with that, but if for some reason you're working through a formula and you're trying to take the square root of a negative number, that means you've done something wrong. Okay, so if you can kind of tuck that away in your brain, if you are ever having to take a square root of a negative number in this class, that means there's a calculation error somewhere. Okay, so then what is the inverse of squaring a number? This should sound familiar. Okay, so again, the word inverse is just a fancy way of saying what's the opposite. So what is the opposite of squaring a number? It's taking the square root. It'll be really important that you remember some of these relationships, right? So the opposite of taking the square root is squaring something. The opposite of addition is subtraction. The opposite of multiplication is division. Some of these things will help you when we're doing some of this quantitative reasoning or mathematical reasoning as we move through the semester. Because a really big part of what we're going to be doing in this class is actually understanding the information rather than being tested over calculations. We will definitely do some work where we're working with calculations, but when we go to our test, I'm not going to be testing you on calculations. I'm going to be testing that you understand what we're doing. So while we're working through this, this lecture, all the future lectures, what you're going to want to be doing is making sure that you're taking notes. So if you haven't been taking notes, you really need to treat this as a face-to-face class. And if you rather be in a face-to-face class, my face-to-face version of this class has room. So you are welcome to join that. You'll just have to look into scheduling and if it'll work for you. Okay, so now I want you to round the following number to 2 places past the decimal. So look at this. What would you do? Okay, so there are different methods of rounding, and we're going to use a very particular one in this class, especially because with it being online, it's going to be really tricky and really important to make sure that you're showing all your work and that we're rounding exactly the same way. Okay, so for this class, we're going to round to 2 places past the decimal. So in order to know what to round to in 2 places past the decimal, we need to look at 3 places past the decimal. So in this example, the 5 is what we're looking at. So 0.765, we're going to look at the 5 to see what we do to the 6. Okay, so if 3 places past the decimal is 5 or above, we're going to round the second past the decimal up. So in this case, we see that it's 0.765, that's 5 or above. So we'll round that 6 up to a 7. So the answer to this one is going to be 0.77. So if it would have been a 4 or below, then we would have rounded that second place. We would have just kept it the same. So it would have been 0.76. All right, go ahead and convert the following proportion into a percentage. And this might not be something that you've done before. I'm going to keep testing you over this over and over again because we're going to have to be able to think really quickly. How do we convert a proportion into a percentage? All right. So to do this, we're going to move the decimal 2 places to the right and then just add a percentage sign. So although I'm not typically going to test you over calculations or math specifically on our exam or closed book exams, I don't consider this math since all we have to do is just move the decimal 2 places to the right and add the percentage sign. So when we do that, we find that if we're going to convert a proportion of 0.76 into a percentage, we have 76%. Okay, what is the numerator of the following fraction? I'm really digging into our past math skills. What is our numerator? So when we're talking about numerators, this is always going to be the number that's on the top of the fraction. So if we look at 1/2, our numerator is 1. So then what is the denominator of the following fraction? So we have 33 103rds. Okay, so when we're looking at this, what is our denominator going to be? Well, to understand that, we need to define it. So our denominator is going to be the number that's on the bottom of our fraction. Okay, and the answer in this case is 103. All right, let's get into some more tricky fractions here. And so when we're looking at this, what does 1/4 plus 1/4 equal? So when we add fractions with the same denominators, it's pretty easy. All we're going to do is add the numerators together, and then we're going to keep those denominators consistent. Okay, so when we do this, we'll see that we add 1 plus 1. So we add across our numerators, and we have a 2. We're going to keep the denominators the same, and we'll carry that through, and we got a 4, so we have 2/4. If we wanted to reduce that down, though, what would we want to do? That would be 1/2. That's correct. All right, so what does 1/3 times 2/3 equal? So when we multiply fractions, we multiply across. Whenever we're doing any sort of math for this class, it's really important that you're writing out all your work. So here we have where we multiply our numerators across. So 1 times 2 is 2. So that's for our numerator. And then we're going to go ahead and multiply our denominators across. And then we see that 3 times 3 is 9. All right, what is 65% of 100? So to do this, the way that I would teach you, because it's not always going to be these nice, pretty numbers, is to convert 65% into a proportion and then multiply that number by 100. So here, if we want to convert 65% into a proportion, we are going to take the decimal and move it 2 places to the left and then remove the percentage sign. And so we see that if we're going to convert 65% into a proportion, we have 0.65. And then we multiply it by that 100, and we find that 65% of 100 is 65. What is 34% in proportion form? All right, so again, to do this, we're going to move the decimal 2 places to the left, and then we're going to remove that percentage sign. Okay, so the answer here is going to be 0.34. Okay, what is -3 squared? Again, when we square something, we times it by itself. So -3 times -3 is 9. And if we remember from earlier on in this review, anytime we square a negative number, the answer is going to be positive. And that's really important to be able to remember as we're going to start working through some pretty complicated rationales for why we're doing different things in this class. Okay, so what number is in the hundredths place in the number 7.368? All right, so let's look at this cute little graphic here. So we see that 1 place past the decimal is our tenths place. 2 places past our decimal is our hundredths place. 3 places past our decimal is the thousandths. That's really hard to say for me, okay? But when we see here, so what number is in the hundredths place in the number 7.368? Our answer there is going to be that 6 right there. Okay, so if we're going to keep trying to review with that, what number is in the tenths place and the number 100.879? So try to remember what we just reviewed on the last slide. Also, this is an online video, right? You can hit pause anytime you want. Make sure you're working through these at your own pace, and pause it if you need to. Rewind if you need to. Make sure you're using these to study for what we needed to know. Okay, so if we look here, one place past the decimal is our tenths place, and here that answer is going to be 8. And there's our cute little graphic again. All right, so then here's another tricky one. What is the absolute value of -9? Again, this might be something you haven't seen for a few years or more. What is the absolute value of -9? Okay, so the symbol for absolute value are two vertical bars. So if we have those two vertical bars and a number in between, around a number, we're saying that we need to take that absolute value. And when we see these absolute value bars, we know that the number needs to remain or turn positive. Okay, so here we see that the absolute value of -9 is +9. All right, so here we're going to look at these number. Which of the following numbers is the smallest? So we have -3, 3, -1, and 2. And this seems like it might be easy, and maybe it is, maybe it's not. But this is actually kind of tricky if we think about it. Which one of these numbers is the smallest? The answer here is -3. So if we were to draw a number line, we had 0 in the middle, right? And so it's going to be opposite because I'm looking at you, but the further we move away from 0 on the negative side, the smaller the number is. And that can be confusing for people sometimes because when we have -1 and -3, on the positive side, it's opposite, right? So -3 is smaller than -1 because it's further away from 0. This is also something that you're going to need to remember as we move through the class, especially as we move later on in the semester, when we're starting to deal with some negative numbers and some really abstract things. But for now, hopefully, this is a good reminder of that. All right, so what is -1 minus -7? What do we do here? All right, so I like to think of a phrase, the enemy of my enemy is my friend, okay? So if we subtract a negative number, all that does is just convert it into an addition problem. All right, so -1 minus a -7, if we're writing out each of our steps like you have to do for this class, we'll have -1 plus 7. All right, so when we do that, we find that our answer is 6. All right, so solve for x in the following equation. And so what we see here is we have 2x minus 3 equals 10 plus x. So what do we need to do first here? We need to get all of our x's on one side and the numbers on the other. Typically, when I'm doing this, I'm going to try to move all my x's to the left side of the equation and all my numbers to the right side because that's just how my brain works, right? So when we do that, what we have to do to figure this out is we actually have to take, if we're trying to get rid of the x on the right side of the equation, we need to have x minus x, and anything that we do to one side of our equation, we have to do the other. So if we take a minus x on the right side of it, we also need to do that on the left side. So if we have 2x minus x, that leaves that number as x minus 3 equals 10. Then we're going to want to move that -3 over to the right side. So we'll have x minus 3 plus 3 equals 10 plus 3. And then when we solve that in the next step, we see that x equals 13. Okay, what is 20% of 40? So if you remember, what are the steps that we need to take to be able to find a percentage of something? What do we need to do that to that 20% first? What do we do first? We got to convert that 20% into a proportion. How do we do that? Okay, so we're going to take that decimal place and we're going to move it 2 places to the left. We're going to remove that percentage sign, and we'll see that if we convert 20% into a proportion, we have 0.20. Then we're going to take that proportion and multiply it by 40. And when we do that, we find that 20% of 40 is 8. So I hope that was a really good review for you. If you're still struggling with some of these are things that I'm hoping you're coming into this class with. Just because this is an online class doesn't mean you can't come into my office hours. And I actually really encourage you to come into my office hours to get help. If you can't come physically into my office hours on campus, we can always set up a Google Meet or something like that. I just want to make sure that if you're struggling with some of the things that we went through in this review, that we're making sure that we're working through some of those things right away so that they don't become problems later on in the class. I'm really excited about this class. It is okay to be nervous. When I started teaching this class, a while ago, over a decade ago almost, I was really nervous to do it too. Okay, so I am here. We're going to try to get through this. I know it's online, but we're going to do the best we can. All right. I look forward to a great semester.